let's have a quick look at our first little bit of probability. Who remembers the 3 ways that we can express probability? Let me know in the chat. There are 3 ways.
We have Ben saying a tree diagram. Drop more responses, guys. Don't be shy.
I normally give an answer.
Shaima and Zoleka says a 2-way table.
Okay, good. Those are 2 ways to represent. So we've got representing probability down. Great. Tree diagram, 2-way table. Yes, fractions. That's 1. Great. Good memory, Ben. Okay, so the first way we express probability or answer a probability question is using a fraction. How else can we express? Decimals. Good. And percentage. Well done, Ben. Okay. So it is very important because they could ask you to give your answer in any of these forms, but fraction is always our default form. So if I just had to ask you for the probability of a certain event taking place and I don't specify anything, your answer would be a fraction. Remember, your fraction needs to be simplified though, otherwise you lose quite a few marks. So simplified fraction. Then if they ask you to give your answer as a decimal, all you do is take your simplified fraction, you press the SD button on your calculator, and then you'll get your decimal. And remember, decimals need to have 2 decimal places. And then if the question asks you to express your answer as a percentage, all you do is take your fraction times 100. And percentages also need to have 2 decimal places. Okay, so when in doubt, always round to 2 decimal places unless they state otherwise. Okay, so just a reminder though, decimals, we use the SD button on our calculator. To convert to a percentage, we just times by 100. Okay, then, nice. Well done, everyone. Thanks for your answers there. How do we work out probability? Do we remember how we are working out our fractions? What kind of formula did we use? Any takers?
Not a single one.
Okay, so just a reminder, when we are working out probability, we take the number of favorable outcomes. So this might be a screenshot moment. Not might be, it is. Over the number of possible outcomes. So we'll see this formula in practice now, but we did try it out in our previous lesson. Does that ring a bell? Okay, so what we've got on the screen is pretty much Monday's lesson in a nutshell. We went through expressing probability in fractions, decimals, percentages, as well as using the formula for probability. Okay, you can't see what I'm writing. Let me quickly check. Okay, while I figure it out, can I ask you guys to complete this table for me so long? It's just practicing converting between fractions, decimals, and percentages. Sorry, Kia, what'd you say?
I was saying we can now see the screen. There's words on
Oh,
it.
can you see my
So I
handwriting?
just tell everybody to take a screenshot. Yes.
Okay, then ignore what I said. Can you all see now?
There's somebody whose mic is on. Can you please, Lerato, hi. Can you please switch off your mic? Thank you.
This is a great day for all the technical issues. Okay, everyone. So like I said, this is a nutshell of Monday's lesson. So let's have a quick little recap activity. So just practicing how to go from fractions to decimals to percentages. I'm going to give you guys a couple of minutes to please complete this table. If you have any questions, don't hesitate to let me know. No worries. We kind of have just gotten into our real exercise. So don't worry that you just joined in now.
There we go.
Okay, I think we're back up. Now we can finally get started. Awesome. Sorry, everyone. I do apologize. I'm not sure what's happening. Okay, so we need to fill in the numbers in this table to show the probabilities in different number formats. So just a quick recap from Monday, just practicing how to convert between fractions, decimals, and percentages. Can I give you guys 2 minutes to quickly do that for me?
No problem, Annalisa. We are all having problems today. Join the club.
Cool, I'm seeing some answers coming in. Great. If you have the answer for the first missing column, you can let us know in the chat. I see some have already come through. Any other answers? Yeah, I was about to say, Shahima, what is happening with that second answer? Okay, I'm seeing some beautiful answers coming in here. Nice. Shahima, did you fix that second one? Tuleka, nice. Bontle, nice. Lihle. Cool. Okay, so they're all coming in different orders. So if anyone's following, it is all muddled up, but we'll go through it now. Okay, cool, great. So let's have a quick look at this. So looking at our first row, we've got a fraction of 3/4 in decimal form. So all we had to do was, if they did ask, put 3/4 into our calculator, press the SD button, and you'll get your answer of 0.75. Okay, and to turn that into a percentage, you times by 100, so your percentage is 75%, which most of you got. So well done. Then the next one, we were only given the decimal fraction amount. So you can put that into your calculator, which will then give you a fraction of 3/10. And either one of those you can times by 100 to get your percentage of 30. Okay. Then if we look at the next one, we've just got 10%. If you put that in your calculator, press equals, you'll get a fraction of 1/10 or 0.1. You might need to press the SD button either way to either get the fraction or the decimal. Likewise, with the 90%, you put it in your calculator, press equals, and it'll either give you the decimal amount or the fraction amount, and you just press SD to get the other answer. And then the last one, you just put 1/8 into your calculator, press the SD button to get an answer of 0.125. And if you times that by 100, you get the percentage of 12.5%. Okay, which most of you did get. Well done. Okay, so looks like we're all comfortable converting between those, which is, yeah, really important probability because they could ask you to give the answer in any one of these forms. Great. Let's look at question 2 now. Says, look at the 5-sided spinner below. When we spin the arrow, it has an equal chance of landing in each triangle because they're all the same size. Okay, so we're looking at this spinner. It's labeled 1, 2, 3, 4. There are 5 equal sides. List all the possible outcomes for getting an even number. What do we mean by that? What are possible outcomes for getting an even number? Okay, so nice. 2 out of 5 chance, 2 out of 5. Okay, so we would answer 2 out of 5 or 2/5 if they ask for what is the probability. But now they want to know what the possible outcomes are. So what actual numbers is it going to land on? What are our even numbers in the situation? Our possible outcomes is that it could possibly land on 2 and it could possibly land on 4. Those are the only possible numbers, even numbers that it could land on. So that's what they mean by possible outcomes. Nice, Emitle, well done. Okay, so keeping that in mind, what are the possible outcomes for getting an odd number? So they're not asking for probability. What would the possible outcomes be for odd numbers? It could possibly land on 1, 3, and 5. Good. 1, 3, and 5. If it asks for the probability of it landing on an odd number, then you would say 3/5. If it asks for the probability. Cool. Okay, looks like you got the gist of this. Well done. So just remember the difference between listing possible outcomes, so what could it possibly land on, and versus probability. Then looking at the same scenario, it says, is there an equal chance of getting an odd number and an even number? Do we have an equal chance that it could be even or odd? No. Good. Why are we saying no? Good. Okay, so no, because there are more odd numbers. We have 3 odd numbers and 2 even numbers. So there isn't an even chance that we'll land on either. Cool. Well done, Ben and Imihle. You guys are on fire today. Keep it up. All right. So that was just 2 little quick recap exercises to get us into the swing of things. Are you guys ready for some real probability questions? Let me know in the chat. Let's see some interaction here. Yes, 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 yes. Okay, the yeses have it. Let's have a look at our first exercise. So let me know if I need to zoom in a little bit more. Okay, so looking at exercise 1, it says, Michaela is preparing for her 13th birthday. She's planning to have a sweet-themed birthday party. She decided to have a big bowl of different colored suckers on the table. She bought a big packet from Macro containing a variety of 80 suckers. When she opened the bag, she saw that there were 15 green, 18 red, 14 pink, 10 blue, and the rest were yellow suckers. Okay, let me just zoom in a little bit more. Okay. So now generally with a probability question, it's a little bit of information overload. So we just need to have a quick look and maybe highlight some important things. So I would say the total amount of suckers is important. There's 80 in total. And then obviously the different colors, 15 green, 18 red, 14 pink, 10 blue. The rest were yellow. So we don't actually know the yellow amount. Okay, so we're just gonna keep that in mind. Okay, so having a look at question 1, it says, what is the probability that a sucker chosen at random will be yellow? Oh, of course they're gonna ask about yellow because they haven't given us the yellow amount. And I see Imihle has already answered. Imihle, do you want to tell me how you got that answer? Or Bontle, either one of you? Bontle raised their hand. Let's hear it. Let's quickly unmute you.
Okay. Hi.
Hi.
So what I did, I added all the colors. Isn't it is 80 in total?
Yes.
So I took that amount that I got from adding all the colors and then I subtracted from the 80 suckers.
Okay.
I subtracted from the 80 and then I got the answer.
Okay, cool. So you took the 80 and you minus all the numbers we did know. So the 15, the 18, the 14, and the 10. And what was your answer when you minused everything?
It's 23. Yeah, it's
23. Perfect. So that means there must be 23 yellow suckers because all of them added together must be 80. Great. And then what did you do?
And then the total is 80, right? It said 23 over 80.
Good. Okay, so just remember when we write out our answers, we say P and then P for probability and then yellow in brackets because that's what we're looking at. And then we put it in fraction form because they haven't specified, so it's our default. And Bontle, is that simplified?
Let me check.
Okay.
No, it's not.
Is it not?
Let me check.
So just a quick one, you just put it in your calculator as is, press equals, and I'll tell you if it's simplified or not, or it will give you the simplified version.
No, it's not. It doesn't give me any simplified.
Okay, so is it at its simplified form already? In its simplified
I think
form?
so.
It is. Well done. Thank you so much. What a beautiful answer. Thank you, Bontle.
Okay.
Well done. Okay, so looking at a question like this, guys, it could easily be 3 marks. 1 mark for working out that there's 23 yellow suckers, 1 mark for the correct numerator, 1 mark for the correct denominator. So something like that can easily be 3 marks. Happy days if we get this in an exam. Okay, and I see quite a few of you also put the explanations in the chat, so well done. Looks like you all understood that. Good. Then number 2, what is the probability that a sucker selected at random is pink? Give your answer as a percentage. Okay, so just a reminder, we say P for probability, we put pink in the brackets, and then we answer. Cool, and I see we've got some answers already. Nice working out in Sako. Okay, so we first put it in fraction form. There are 14 pink suckers out of the 80, but they don't want a fraction, so we're going to times by 100, so we can convert to percentage, and that gives us 17.5%. Okay, we don't have to worry about 2 decimal places here because there was only 1 decimal place. Well done. I see most of you did get that. Great stuff. Okay, what is the probability of selecting a blue or red sucker? Give your answer as a decimal. So a key thing to remember here as we're looking at blue or red suckers. Sure. Been on fire today. Annie Mikle, well done. Nice. Just remember that you don't need to put that percentage sign in afterwards, hey, Mikle, because we're just doing decimals. And I love the format of your answer. You remember the P and the brackets. Okay. Any other answers coming through? Nice, Leafle. Again, you don't need to put the percentage sign in because we're actually looking at decimals. Nice. Kat also reminded us. Okay, so probability. Oh, doing it in highlighter. It was red or blue. And if you add the red and blue together, it's 10 plus 18. So it's 28 over 80. And we want it in decimal form. So you just press the SD button and you get 0.35. And then hopefully a nice and easy one. What is the probability of picking a black sucker from the bag? Nice. Good. So you can say 0, 0 over 80. Nice. Sometimes I like to throw these questions in there as a trick question. Okay, so P. Cool. Nice. Well done, everyone. You're doing so well. Okay. Let's see how the next one goes. Hopefully just as good as this one. I think you guys have got it though. Let's have a look at exercise 2. So it says, a company developed a deodorant which they claimed would keep you fresh 24/7. The deodorant, was tested on a group of people. The results were as follows. So we have a group of people who thought the deodorant was effective, which was 62 people, and 28 people said the deodorant made no difference to them. So for the first question, they have asked, how many people participated in the test? How would we work that out? Sure, quick maths, yeah. Okay, so I see all of us have written 90. So for those of us nice and cycle, it is 62 plus 28. So just remember, I know it's just easier given the answer on the chat, but when you are doing your working out, please show all your steps, because in an exam, this would be 2 marks, 1 for method, 1 for answer. Nice, everyone. Okay. I'm going to leave you to do question 2 and 3 for me. Let's go. Keep your answers off the chat for now. I just want to give everyone a chance. So just try question 2 and 3 for me. I'll let you know when you can share your answers. So, okay, question 2. So I'm just getting all the answers in different, like all jumbled up. Okay, so let's have a look at question 2 specifically quickly. I'm going to give some more space here. All right, so we're looking at the probability of the effective group members. So there are 62 out of the 90 people who say that this deodorant is effective. We want it as a decimal, so we press the SD button and we get 0.6888, which is actually rounded to 0.69. So that's one of the common mistakes I saw there, is the rounding. Okay, and I think, was it Ziri, if I'm saying your name correctly, Zirilile, because it's decimal form. If it was 68, it would be percentage form. So they wanted decimal form, so it stays at 0.69. If they wanted percentage form, we would times by 100, and then it would be the 69%. Okay, then 3, I think I saw a lot of correct answers there. 0, okay. So I think we're mixing up. Question 1 wanted our answer as a decimal. Quite a few of you gave the answer as a percentage. And now for question 3, they wanted the answer as a percentage, but quite a few of you giving me the answer as a decimal. So let's just quickly check that out. Okay, so P, the probability of no difference, the people who feel like the deodorant made no difference to them. It was 28 out of the 90. So that is our default answer, but because they asked for it as a percentage, we times by 100, which gives an answer of 31.11%. Don't forget the percentage sign. And remember, 2 decimal places with percentages. Okay, so the takeaway from this is, please make sure we are reading how they want the answer given. But for the most part, the working out was correct. Cool. Let's try question 4. So it says, If 688 people were to buy this deodorant, how many of them could the company expect to be unhappy with the deodorant? So now we have an actual number of people buying. Based on all our working out, we know the percentage of unhappy people. The percentage of unhappy people is the 31.11%. So what am I going to do with that percentage and the number of people to see how many people could be expected to be unhappy? Any takers? Nice, and Nsako, well done. Okay, so all we need to do is take the number of people. So we've got an actual number of 688 people times by the 31.11%. We put all of that in our calculator, including the percentage sign, and we get an answer of 214 people. So just based on that little survey and the probability we worked out, the company can expect roughly 214 people to be unhappy based on our calculations with the percentages. Yeah, Seamus, same. I'm also struggling with network today, so don't stress. We're just going to try our best. We are managing to get through the work. So if you need to screenshots, do it as often as you can, and then you won't be too far behind. Well done, nice, and Nsako, sorry, Buntle, and okay, yeah, just you two. Nice answers. Any questions, guys? We feeling good still? Feeling confident with probability? Hey, are you guys ready to try a tree diagram? Do you guys remember doing tree diagrams last year? Let me know in the chat. How do you normally feel about tree diagrams? I know it's a hit or miss for the most part. You ready to try one? Excited to try one? Not normally your thing, but open to learning it from scratch? Let me know in the chat. Haven't done it before. Okay. Saku, you don't remember much of it. Okay, cool. Anyone else? Wantley, you still remember? Good. So you're going to help us out when we do our questions now. Who else? Emihle, Ben. See your friends had thumbs up. Okay, so let's give a tree diagram a try. Looks like we may have to just start from scratch, which is totally fine. Let's get the basics sorted so we can kill it in the next lesson when we really get into tree diagrams. So just a reminder, tree diagrams is a diagram using branches to display all the possible outcomes of the event. So the keyword there is branches, and you'll see it looks like a tree. So now let's look at an example together. What is the probability of flipping two coins and they both land on tails? Use a tree diagram to show all possible outcomes. Okay, so it's normally easier to find the possible outcomes when you have set up and drawn a tree diagram. So let's have a look. We are looking at two coins being flipped. So I'm going to first focus on coin one. Coin one has two options. It can either land on heads or it could land on tails. Then I'm going to look at coin two. So let's say, for example, I've thrown coin 1. It has landed and it's landed on heads. Now I'm about to toss coin 2. Coin 2 can either land on heads or tails. So I could have an option of heads and heads, or heads and then tails. Or I've tossed coin 1 and it's landed on tails. When I toss coin 2, it could land on heads or it could land on tails. So that's a really basic small tree diagram. We then fill in the last column, which is the important column. It tells us all our possible outcomes. Okay, so we could say this is how we basically read the outcomes. First coin landed on heads, second coin landed on heads. So that means we could have an option of heads and heads. Or we could have first coin landing on heads, second coin landing on tails. So we have heads and tails as our next possible outcome. Nice, Bontle. Then we could also have the first coin landing on tails first, then the second coin lands on heads. So it could have an option of tails first and then heads. Or it could be tails and tails. So by throwing those 2 coins, we have 1, 2, 3, 4 different options that could happen. And those are our 4 outcomes. So there are 4 possibilities. Nice, Tamia. Okay. So if we go back to the original question, it says, what is the probability of flipping 2 coins and they both land on tails? How many times do you see both coins on tails? Just over here. And that is once out of the 4 possible outcomes. So if you had to work out or show you're working out probability of tails and tails, you would say 1/4. Nice, Ben. Hey, how does everyone feel about that? Feeling good still? Do we understand? Do we have any questions? Yeah, it's not too bad at all. So that's one way you can be asked about a tree diagram. You can actually draw one from scratch, or they can give you a partially completed one and ask you to complete it, or give you a full one and you have to answer questions based on the tree diagram. So let's try another one. This one, we had to draw a tree diagram from scratch. This one, we've been given. Now it looks really intense, but it's not that bad. So let's first look at the question before we look at the tree diagram. So it says, the local old age home will prepare sandwiches for tea time. The sandwiches are made from an equal number of white, so abbreviated with W, brown, and whole wheat loaves of bread. So there are 3 types of breads being used for these sandwiches. The fillings used for the sandwiches are egg or fish, with mayonnaise or without mayonnaise. Okay, so now it says, look at the incomplete tree diagram and answer the questions that follow. So just quickly have a look at the abbreviations again. B stands for brown. This is white bread. And H is our whole wheat. So if we have a look at our first part here, that is brown bread with egg as the filling with mayonnaise. That's the BEM. Or brown bread with egg and no mayonnaise. That will be the BEN, for example. So that's how you read the tree diagram. Or it can be brown bread with the fish filling with mayo, which gives you BFM, or fish without mayo? That's the brown bread with fish, no mayo. Okay. So keeping that in mind, let's see what the first question asks us. Explain what the outcome BEM represents on the tree diagram. Oh, and I feel like I've already answered that question. What does BEM stand for? Good, Zuleika. Nice. Asipe. Brown egg mayonnaise. Brown bread with egg filling and mayo. Nice, Benita. What a beautiful full answer. Okay, so BEM stands for brown egg and mayonnaise. Good. Then complete the tree diagram. So as you can see, we have some missing outcomes over here, here, and here. So I'm going to label it 1, 2, and 3. So if you can give me your answers in that order, that would be perfect. Oh, sorry, I see I've forgotten one. Thanks, Avi. There's actually 4. Nice. Oh, these answers are looking good. Anyone else want to try? Okay, so looking at the first one, it starts with the white bread. So it's W, and it's got egg as the filling. And we're looking at the N following that line. So it's WEN. And it looks like most of you did get that. Well done. Nice offensive. Then the second missing one is by the WFN. WFN. Good, Segofatso. Then 3 is with our whole wheat. So it's HEM. So whole wheat, egg filling with mayo. So HEM, and the next one is whole wheat with fish and mayo. So HFM. Nice. Okay, so looking at all these combinations, how many possible outcomes do we have based on this tree diagram? How many possible outcomes do we have? So we'll put it underneath here. Well, good. So all we do is go and count our outcomes on the side here, and you get 12 outcomes. So even though it doesn't seem like many options, you've actually got 12 different types of sandwiches based on those 2 fillings, having mayo, not having mayo, and 3 types of bread. Nice. Okay, so if I had to ask you just one last question, what is the probability of someone choosing a sandwich that contains brown bread? What would the probability of choosing a sandwich with brown bread be? Nice. Okay. I'm seeing half answers here. Let's see if anyone picks up what I meant by half answers. Okay. Vanille, so I said, what is the probability of choosing a sandwich that is made from brown bread? Okay, so let me just quickly erase this so it's nice and clean. So as you can see, you would need to now look at the outcomes column, which is on the end here, and see how many times you see the letter B, because B stands for brown bread, okay? And you only see it 1, 2, 3, 4 times out of the 12. So yes, the 4/12 part was correct. However, can that not be simplified to 1/3? Nice, Shahima. All of the above. Okay, cool. So I see quite a few percentage options here. I wasn't asking for the percentage. Remember, I didn't specify, so you must always answer as a fraction unless I ask for a percentage or a decimal. But the key here is that pretty much everyone forgot to simplify the fraction. So just remember, in a test, you were going to mark for your actual answer and then a mark for your simplified numerator, mark for simplified denominator. So you could lose out on 2 marks if you do not simplify. Okay. Nice, guys. So it looks like you really are getting the hang of some tree diagrams, which we are going to get into more detail next week, Monday. How are we all feeling after today's lesson? How do we feel about tree diagrams? We're excited to learn more? Vanilla, you can just unmute and ask your question.
Ma'am,
Hmm.
your question said how many sandwiches will be made out of brown bread, right?
Yes.
So we don't look at the fact that there is 3 kinds of bread, which is brown, white, and whole wheat.
Well, we do. So remember, all these outcomes on the side here that I'm going to circle now, those are the only outcomes we have. But now I'm not going to include the white bread and the whole wheat bread because I just want to know what is the chance of getting brown bread. So that's why I only looked at the brown.
Oh, so we only look at the outcome, not the first part of the tree diagram.
No, just the outcome column, always.
Oh, okay. Thank you, ma'am.
Okay, pleasure. Okay, great. Okay, so I'm just going to quickly put the poll